ACT stuff. According to my notes, we went through 25 last time, so let's start on 26. Hold on a moment. All right. It's the slope of the line containing those 2 points. This is one of the most basic things in algebra.
It would be I would think it would be 1 over 15 rise over run.
Well, you got that part right. The rise over the run. What's the rise in terms of the x and y coordinates?
Oh, I screwed up. It'd be fifth. Yeah.
Yeah, it's that. In other words, the rise is the change in the y coordinates. And that's 15 over 1.
Yeah, definitely. Oh, well, yeah.
Okay, here's one of the conic section questions. Remember, there's 2. The only thing you have to know is the equation of a circle and the equation of an ellipse. Tell me the general equation for a circle.
Then just like what do you mean?
If its center was at the origin, then that's the equation. But the general equation, regardless of where the center is, and you want to memorize this, where H and K are the center and R is the radius.
All right.
So which one fits this?
It would be B.
Good.
Yeah, that's what our guys are.
Got a little bit of interference here. It almost sounds like there's another meeting somebody's having that I'm hearing the audio from.
Yeah.
Do you hear that also?
Yeah, my dad's behind me on a meeting.
Oh, that's probably what it is. Sorry. What's the general equation of an ellipse? That's the only other one you have to know.
Isn't it just half of that?
No, it's similar to this.
Is that your wife?
The top part is pretty close to the same, but it's equal to 1, and there are 2 different radiuses. In other words, if I draw a picture of this ellipse, the long radius is A, short radius is B. Now, technically, they're not called radiuses, but you can think of them like that.
Yeah.
Okay? And if it is I don't think you're actually going to have to handle the vertical ellipses, but if I had an ellipse like this, well, this is A, and that's B. In other words, the long radius is always A.
All right.
And A has to go under the proper variable. In other words, because the long radius here is parallel with the x-axis, then A goes under the x coordinate, or the x variable. In this picture, A is parallel to the y coordinate. So this would be under a squared, and that would be b squared. In other words, if you find an ellipse that has this format here, you know it is a vertical ellipse. And the most important thing, a is greater than b. So if I told you that x over 4 plus y squared over 9 is equal to 1, is that a horizontal or vertical ellipse?
That's a
So if I
horizontal. No. That's
A has to be bigger than b, so this has to be a squared.
okay.
And because the a is under the y, it means we have a vertical ellipse because that is always measured along the y-axis. Or a vertical ellipse. For a horizontal ellipse, it's always measured along the x-axis, so it comes under the x. But in other words, if they give you this, you have to recognize a couple of things. First of all, the center is at the origin. And second of all, a is under the y variable, not the x variable. And if a is under the y variable, it is a vertical ellipse, not a horizontal one.
All right.
That really is the only conic stuff you have to know. And there's only 2 questions on conics. So if you can remember those 2 formulas, those basic formulas right there, you're going to get both conic sections correct. Or both conic questions, I should say.
All right.
About this one.
So
And they're saying that that factors into this. What does A have to be?
it has to be
You wanted to say it? Go ahead and say it.
2.
Yes. In other words, the only part you really have to know is that times that has to equal 8x squared. And for that to be true, A has to be 2. Well, if A is 2, then that times that is minus 6 also. Okay? So this is really an easy problem. It's one of those problems that it's easy to make difficult. In other words, if I start thinking about factoring stuff out here, in other words, if I take this step here, I'm going to make a big mistake. Because now it becomes less obvious what A is, not more obvious.
All right.
Only thing you have to know is that this term times that term equals your quadratic term. And that tells you A has to be 2. You don't even need the last part.
Right.
Okay. This is a problem you definitely should know how to do.
Yeah, wouldn't it just be D because
Remember that we're talking about a line that is perpendicular to this line.
yeah.
Therefore, what is the slope of the perpendicular line to that line right there?
Oh, it's 4x.
It's just 4.
Oh yeah.
Okay, so that eliminates our answers to either A or C. Okay, Now,
Yeah.
we have a slope and a point. How can we get the equation of that line? What's the point slope format?
I don't remember.
Well, you don't have to know it, but it's useful to know. It's because, I mean, we could figure it out with the slope-intercept format, and I'll show you maybe both ways, just because there's the slope-intercept format. Excuse me. There's the point-slope format. The reason it's called point-slope is because you have exactly one slope and exactly one point. So if I filled in for m and the point, what would I get?
You would get y minus 4 is y minus 0. Right?
What's y
So-
minus a negative 5?
Y plus 5.
Slope is 4.
4.
What's
then-
the x point?
X minus 0. Oh, yeah.
So the equation, in other words, they didn't give it to us in point slope. They gave it to us in slope intercept. So let's mix this up, and which one is it equal to?
It would be A.
Yeah, 4x minus 5. Now, let's just go back for a moment because I don't want to ignore this. We don't actually need point slope format. If the only thing you can remember is y equals mx plus b, which is slope intercept format, well, we know the slope, so that we can fill in for that, and we know one point. So we know what the x is and we know what the y is. I can solve for b. So if I fill in the y as minus 5, and I fill in the m is 4, the x is 0, that allows me to solve for b. Notice that b is equal to minus 5. Once I know b, then I know y equals 4x minus 5. So I don't have to know point slope format to solve this problem. I can do it just fine using slope intercept. It's maybe slightly easier using point slope, and point slope is something you should be familiar with, although I can't honestly say you're absolutely going to need it for the ACT test. You could probably get by with just knowing slope intercept format. Y equals mx plus b. But you have to know if you are going to use y equal mx plus b format, then you have to know that, okay, you can substitute for m, and you can substitute for x and y, the point that you know, and that only leaves one variable, meaning you'll be able to solve for b. And once you solve for b, you can put it back into its y equal mx plus b format.
It would require 5 cups of flour.
Okay. Yeah, this is a ratio problem. 24 is to 2, and maybe it helps if we put the units on there. 24 cookies is to 2 cups of flour as, Well, the 60 cookies is on top. That's the advantage of using the units. So there's our ratio. And if you do the math, you get x equal 5. So 31. We have 0.1 times p plus 1800 equals p. So they're asking you to solve for p. Tell me how to solve this equation. In other words, I don't want just the answer. I want to be sure you know how to solve this equation, even if it wasn't multiple choice.
Alright. So would you just multiply both p and 1800 by 0.1?
Yep. In other words, first step in solving an equation is to get rid of the parentheses, get rid of the denominators. Well, there's no denominators here. Let's get rid of the parentheses, meaning let's distribute that. So what do you get when you distribute that?
It'd just be 0.1p plus 180.
Next step.
And then you can, could you just subtract 0.1p?
Yes, that's the best way to do it. In other words, there's no rule that says p has to be on the left. We can make p on the right and leave the number on the left. So if we subtract 0.1p from the right, what do we get?
Wouldn't it just be 0.9p?
Okay, now what's the last step?
Dividing both sides by 0.9.
What's 180 divided by 0.9?
200.
Yeah.
No.
No, that's the correct answer.
Yeah.
Now, I do think it's extremely important that you know how to solve this equation properly. However, notice that we could have back solved this thing.
Yeah.
Right? In other words, I could just check all the answers. Does 200 work? Instantly, if we happen to start with 200. But if we started with 1620, it wouldn't work. And we could just go through all 5 answers until we found the right one. But the quicker way is obviously the algebraic way. And that's really what it's all about on the ACT. It's not so much using one method over another, it's using the method that's going to give you the answer the quickest. Okay, knowing the general equation of a circle, what is the equation of this circle?
So it would be K. Oh, yeah, K.
First of all, find the center. They haven't given you the center. They've given you a point on the edge.
Yeah, so the center is 3, 0.
Okay, so H has to be 3.
Yeah.
But what does Y, or what does K have to be?
Okay. K has to be 0.
Okay, so this K can't be correct. Okay, so let's find another thing that's got x minus 3, because that part's correct. Is F correct? What's the radius of that circle?
3.
And this needs to be r squared, so 9 is correct over here. K is 0, so that's correct. F fits on all regards.
All right.
Okay, so you can see, I mean, here we've run into 2 conic questions in a row, and both of them only required one thing. You only needed to memorize the equation of the circle and the ellipse. You have to do a little bit more for this problem in that they didn't give you the precise center. They gave you this point, but that allows you to come up with an h of 3 and a k of 0. Once you get h of 3, k of 0, r of 3, that's the only thing that fits. So, make sure you have those 2 formulas memorized when you go in to take the test, because the 2 questions on conics are gifts. If you know these 2 formulas, you're going to get both of them right every time. And that's why I say they're gifts. Kind of like the 4 trig questions. The 4 trig questions on the test are going to be gifts for you, especially since you're taking trig. But even if you weren't, the trig questions are so easy. They're like the first 2 weeks of trig. In other words, if you know SOHCAHTOA, you're going to get 2 of them right. And if you know anything else, you'll get 1 more right, and you should get all 4 right. So 2 conic questions and 4 trig questions are 6 questions that a lot of people find hard, but they really, if you think about it, they're 6 gifts. And then you have 54 other questions that are on algebra and geometry. And that's it. Let's make sure we go through this. I mean, sometimes if there's an easy way to answer a problem, I'll show it to you, but I want to make sure you know how to solve this. So, multiple choice or not. Solve this. First step.
So it would be x plus 10 minus 2x is 2x, or 2x plus 3.
Next step.
And then can't you just subtract or just move everything?
Well, the next step is the same next step as if it was an equation.
Right.
In other words, you want to gather all the x's on one side, gather all the numbers on another. The only thing you have to be careful with an inequality is if you divide or multiply by a negative number, you have to change the direction.
Right.
So probably the easiest thing to do is just, let's go ahead and combine those. What do you get?
So it's just 10 minus x. Yeah.
Okay, now choose which side you want to put the x's on and which side you want to put the numbers on.
Just x is on the right.
Correct. In other words, if you can avoid having to divide by that negative number, do so. It's always better to avoid negative numbers if you have a choice. And you always have a choice when you're solving equations or inequalities, is that you can move the variable to the right and the numbers to the left, or vice versa. What's our next line? Once you move all the x's to the right and all the numbers to the left.
It would be 7, and then it would just be 3x.
Notice I have not yet had to divide by a positive or negative number. It's okay to subtract and add positive and negative numbers. You don't have to change the direction. It's only when you multiply or divide or take the square root of. But so x is what?
It would just be 7/3.
And let's make sure we see that answer. Yeah, x is greater than 7/3. Now, notice one thing. The answer they gave had the x on the left everywhere. So another thing that's worth knowing is if you end up with the x on the right and you want to turn this around, you can switch the left and the right, and when you do that, you just have to switch that. In other words, that means the same thing. I think you can see that. In other words, this means x is greater than 7/3. This means x is greater than or equal to 7/3. So don't let them fool you with where they put the x.
All right.
Okay. This one?
That one would be J. Because don't you add when there's two exponents, don't you just add them together?
When you're doing double exponentiation, you multiply.
When do you add them together?
Add whenever you are multiplying the bases. In other words, if I had that, notice that I'm multiplying the 2's. They're the same, so I add the exponents. You always do one level less with the exponents as you're doing with the bases. If I am dividing the bases, if I have 2 to the 4th over 2 to the 3rd, I subtract the exponents. And there's only one other situation, and that's where you have exponentiation followed by more exponentiation. I tend to call this double exponentiation. Well, this is where you multiply the two exponents. So the only thing you need to know to get the correct answer here, if you look at the answers, is they've only given you one a to the 16th. And you know you're going to have to multiply that 4 by that 4 because we have double exponentiation going on. So it's got to be k. It's also 4 to the 4th, which is 256, times a to the 16th. But without knowing the rule, you would have a hard time distinguishing between j and k. In other words, you need to know that when you have double exponentiation, you multiply the exponents.
Yeah.
All right, actually I have a 4:30. So that's a good place to stop. What is that? Number 4 on page 452. All right, Mitch.
All right.
I'll talk to you later. I miss your trig problems because usually you send me trig problems and then I don't need any other student to send me the trig problems for the week because I already have it.
Yeah, it's getting really easy for me, so I don't need
That's good news. That's really good news. All right, keep at it. Talk to you in a week. Bye-bye.
Bye.